Hello, my name is Ken Baker from the Kendrick County Division of Transportation. We are making this video for all residents on non-dedicated subdivision roads that will be using MFT monies. These videos and this instructional that we'll be showing you will be helping you out and become certified so you can use motor fuel tax funds for maintenance of your roads.
Hi, my name is Randy Morin. I'm with the McHenry County Division of Transportation, and today I'm here to talk to you about the non-dedicated training program put on by the McHenry County Division of Transportation. Trees are a valuable asset to our landscape. If you could imagine waking up tomorrow morning to a barren land with no trees, it would be kind of a shock to your system. Trees are a benefit to our communities, our towns, and our landscape, but they do require an investment of time and money. Trees take proper care to make them grow and keep them healthy. I am a certified arborist, and an arborist is defined by an individual trained at the science of planting and taking care of trees. Arborists are knowledgeable about the needs of trees and are trained and equipped to take care of them. Hiring an arborist is a decision that should not be taken lightly. Now let's open it up the tree and we'll talk a little bit about the anatomy of a tree. The outer bark is the tree protection from the outside world. We've all maybe done it at one time or another where we've taken a knife and carved our initials into the side of a tree, thinking this is going to be kind of cool. It's actually not the best thing for a tree. That outer bark, it does protect the inside of that tree. The inner bark, the phloem, is the pipeline which the food is passed to the rest of the tree. That's where the transfer occurs from the root zone up to the crown. The cambium, the cell layer, is the growing part of the trunk. It produces the new bark and new wood in response to the hormones that pass through the phloem to the food to the leaves. Sapwood is the growing part of the trunk. We've all cut a little branch off and it saps up. Sugar maples will sap out really well. The heartwood is the central supporting pillar of the tree. Although it's dead, it will not decay and lose its strength as long as the outer layers are intact. We'll talk a little bit more about decay a little bit later. And then, of course, we've got the leaves. That's what makes the food for the trees. The root system is the organ of the plant that is typically below the surface. Sometimes the roots will come up towards the surface, but in most cases, they're down below, looking for that groundwater so they could absorb the waters and the minerals in the soil. At the end of these roots, there's smaller lateral roots, feeder roots, and these roots are closer to the surface and they are fine hair looking, and the roots absorb the water and minerals from the topsoil. Taproots. One of the biggest misconceptions is that all trees have a taproot. Well, that's really not the case. When we talk about a taproot, it's the main root of the plant. Typically look like how a carrot would grow. Like I said, most trees do not have a taproot. With our soil and the landscape that we have, the roots usually stay within that top surface of the soil. Here's an example of what a tree might look like with a taproot. This example gives you a better idea what your typical root system looks like, but your roots generally will stay pretty shallow, 6 to 12 inches to the surface. Here's another example. As you can see by this example, the roots spread way out beyond the crown of the tree. It is said that when a tree is spaded out of the nursery, 90% of the root system is left behind in the nursery, and then it's balled and burlapped and brought out to the planting site. Again, as you can see in this example, you can see the canopy with the drip line, and that's the distance where you can see the trees, the roots are out past the leaves or the canopy of the tree. Man is probably one of the worst enemies to trees. When we come in with machines and we dig next to trees, we create the injuries, and trees end up dying off. Either we're digging next to them, parking equipment on top of the root zones, compacting the soil. This is detrimental to the life of a tree. Living in the Midwest, we've all maybe driven down a road that looks like this. It looks very pretty, very picturesque when you drive down. As you can see, the snow is hanging on top of the trees. The tree branch does start to hang down a little bit lower to the road. and then they fail. And when trees fail, the branches will fall. And it doesn't necessarily just have to be winter, but they'll fail in the summer and usually across the road if they're a right-of-way tree or a parkway tree. When trees do fail, and typically, again, in our urban landscape, they're either by power lines or around power lines, and they'll take down lines with them. As you can see by this slide, it's not a very good situation when you're responding to an emergency and you see this, or you look out your back window and this is what you see. There's a standard in the industry that states that we as line clearers or certified arborists can't come within 10 foot of an energized line. In order to do that, you have to be a certified line clearer, and those trained professionals are the ones that are out doing the line clearing and keeping that distance between the power lines and your trees. One of the most detrimental things that can happen to a tree is topping. And again, this is a practice that the industry is trying to get away from. Topping is taking out the top section of the tree, or basically just making a lateral cut right on the branch. And by doing this, the limbs will grow back faster, but they'll be weaker and weak-wooded, and you'll have a better chance for that tree to fail down the road. Here's an example of a tree that was topped. My professional opinion on this tree is if this is what you're going to do to it, you might as well made one cut at the bottom and started over with a new tree, with a new planting. Here's another example of trees that were topped. So when we talk about pruning, there's a technique that's very common in the field, and it's called the jump cut technique or the 3-cut technique. As we look at this example, and we started with cut A, we're going to make a cut in the bottom of the branch about 1/3 of the way up. As we move to B, we're going to take that full cut and move through the branch. That cut will either connect itself to A, or that branch will just cut off. By making that undercut on A, the branch doesn't have a tendency to tear that bark down into the actual tree. So when that B cut is completed, you move to the C cut. And as you can see, that cut, that C cut isn't flush to the tree itself. There's a branch collar, or a branch ridge is what we call that, and that tree will have an opportunity to heal itself over by making that cut. Again, back to some of the pruning techniques we see out in the field, is you have your V pruning, which you're creating a V so the power lines can come through that. Your L prune, which basically you're taking off all the branches above the power lines and leaving the branches down below the power lines. And then finally, you'll see the side prune. Well, they'll just take everything straight up the side of that tree, maintaining that distance between the power lines and the trees. Here's an example of a pruning wound that's healed over. As you can see, the wood actually cows over that prune. Now we'll talk a little bit about decay. There are over 50 species of decay and fungus that cause the heartwood decay, which causes the tree to fail eventually. Decay always occurs in a step-by-step fashion. First, there has to be a wound, an opportunity for that decay to get in there. Again, it's typically done by a mechanical injury. Chainsaw, weed whip, lawnmower, and sometimes it is a storm damage. The branch gets ripped down by high winds. Once decay is there, it's a fungi that takes advantage of the opening and enters the tree. Once infected, the woods decay, and the fungi then degrades the sturdiness of the heartwood. Again, here's some examples of decay in the heartwood. If you look at the bark, the outside of those logs that were cut, by looking at that, you couldn't see that decay that's happened on the inside. And here's another example of decay that's set in. And the size of that wound, whenever you're doing a prune, you want to minimize that mechanical injury and keep that prune as small as you can. And here's a couple examples of failure once that decay is set in. Codominant leads. Codominant leads create a weak point in a tree. As you can see in this slide, that those two branches or those two trees that are growing there, it looks like one tree, but it's actually two separate trees growing around each other. A fallacy is in the industry is that those two will grow into each other and create one tree. But in reality, as you can see by this slide, they're growing separately and they grow around each branch and then they end up budding up together. Deadwood is often the dry, brittle part of the tree, and you'll see that up in the crowns. It doesn't bend and it doesn't move like a living branch. Dead branches and treetops often break off and they'll hang up in the tree or they'll come crashing down. And again, in the industry, we call these widowmakers. Here's some examples of some deadwood and some crossing branches. When you go up to prune one of these trees, the idea would be to take out the deadwood, take out the crossing branches. When you're going in to prune a mature tree for the first time, you really don't want to take out any more than 1/3 of that crown. One of the best things that we can do on any type of construction project or even a resurfacing project is use snow fence to protect the root zone of that tree. Tree protection, once it's put up, does need to be maintained. And in an ideal situation, once that, when you first install that tree protection, you want to get it outside that crown of that tree to protect as many of the roots as you can. For whatever reason in the industry, when you put up snow fence or you put up your tree protection around that, the contractors like to use that as their staging for pipes and rocks and other debris. As you can see in this example, the tree protection is up, but it's not doing a very good job of keeping material out of that fenced-in area. Identifying hazards of a tree are things that we go out and we look at doing a visual inspection of the tree. As you can see here, there's a couple different things we've got going on. We've got a crack in that bark, and then we see these tiny little holes. Those are borer wounds from an insect. And when we're identifying hazards, we're looking for things that aren't just not right with the tree. As you can see here by this example, that crack in the base there, you've got the two trees trying to grow together, and with the weight, that's set up for failure. Here's another example. This could have been a lightning strike or a mechanical pruning wound that never had an opportunity to heal over. One of the things we're battling right now in the Midwest is emerald ash borer. And we're going to show a short little video on the emerald ash borer, and this will give you a good explanation of what this insect is doing to our landscape.
Emerald ash borer is a gorgeous little insect. It really is. But what it does is not gorgeous. What it does is hideous.
There's invaders from other countries. It's really difficult to stop a species that has no natural enemies and has open terrain to feed on all the beautiful trees that we have. At Indiana Dunes National Lakeshore, there are certain spots as you walk through the trails where you can see trees that have been eaten and died, and that's tough to see that. You want to see a healthy forest, you want to see a healthy ecosystem for natural wildlife to thrive. I see a tree that could have lived another 100 years. and been an enjoyment for many generations to come. To see it wither and die at such a young age, only 30, 35 years old, is a real sad thing to see. It's amazing how much damage can be done by something so small. We can see lots of damage here.
Oh yeah, but you can see
Yep.
these feeding galleries where this is where the tree dies. This is the larvae come in here. They feed on this tissue that's right underneath that bark.
This particular hole right here is important. It has a straight line and a D-shaped. Now that is the exit hole of the adult. The adult exits in early spring to mate.
And the females come down and they crawl along these crevices laying individual eggs.
When the eggs hatch, the new hatch bores right into the bark of the tree again and starts the process all over again.
And then they move on to healthier trees in the area.
I kind of look for more trees that are healthy, so that's another problem for the spreading.
So this just tells you how insidious this thing is. It's a tragedy. It truly is.
We make 25 to 30,000 ash beds. And the reason why we do ash and birch is because ash has been around since baseball started. Our ash wood comes from primarily Pennsylvania, New York, and West Virginia.
The beetle is there, and it could start affecting us at any time. I've heard about it a couple years ago on TV, that it was destroying trees in Chicago, and never really put two and two together. And now this could really affect our business and everybody else's livelihood in the major leagues too. All by a little bug that's chewing up major profit.
Emerald ash borer has not spread in this country on its own. It only moves about half a mile a year on its own. Emerald ash borer is kind of a devious little insect in that it's often carried unknowingly by people who are moving firewood, people who are moving nursery stock, logs. So it is critical that people understand their very important role in spreading this insect.
The emerald ash borer really stinks because it's plant specific and it's totally killing ash trees regardless of where they're at or the type of ash that they are. Biggest thing that would combat the emerald ash borer and prevent its movement is burning firewood where you buy it. Not taking firewood with you, but wherever you're camping, pick up firewood there.
When we talk about our trees, when all else fails, I say take it with you. Again, my name is Randy Morin, and if you have any other questions, we would like you to direct them to your local township office. Thank you.
We'll be going through videos. The first video is going to be maintenance of gravel roads. Gravel roads will have 3 videos. We'll only be showing you one, but please get onto our webpage. The other 2 videos will be shown on that one, and you could watch all 3 at that time.
The facts are simple but impressive. Of the nearly 6.5 million kilometers of highways, roads, and streets in the U.S., about 2 of every 5 are unpaved and carry over 1/5 of all traffic. Most of these unpaved roads are aggregate surfaced, that is, covered with a layer of gravel. Although you won't find any gravel roads in our interstate system, you will find them making up a large part of our local roadway networks nationwide. And while gravel roads generally carry low volumes of traffic for short trips, they nevertheless are used for a wide variety of purposes, and sometimes by very heavy vehicles. Because they are essential to the local transportation of people and products, gravel roads need to be maintained in good condition. Their users deserve a safe and reasonably comfortable ride. In reality, though, conditions are not always good, and the ride's not always safe nor comfortable. The reason? Scarcity of road maintenance funds? Yes, in part. But there's always a shortage of public works money. Beyond the dollars, many local agencies also lack an understanding of the causes of gravel road problems and are unaware of the proper methods for preventing or correcting them. Then there's the ever-increasing abuse we heap on our gravel roads. Some of the stupendous wheel loads inflicted on them nowadays would be illegal on even our sturdiest pavements. This video presentation was produced as part of the Local Technical Assistance Program of the Federal Highway Administration. Its objective is to help local agencies recognize common problems of gravel roads, understand their causes, and learn how to prevent or correct them. A handbook has also been developed as part of this training course. The video is in 3 parts to allow an opportunity for discussion after each segment. In this first part, we'll examine the environment of gravel roads and the aggregate materials used to surface them. In Part 2, we'll focus on the common problems of gravel roads, what causes them, and how to prevent or correct them. Then, in Part 3, we'll look more closely at maintenance equipment and techniques. Now, just what is a good gravel road? Well, those who get the angry phone calls from upset citizens might describe it as one that doesn't have ruts, potholes, or loose gravel, one that drains well and isn't dusty, one that's smooth but never slippery. Of course, it also must be wide enough for vehicles to pass without driving into the ditches, not too steep, and not too curvy. Oh, and by the way, when are you going to get around to paving it? Well, you can't deny that most people prefer paved roads, nor can you blame them. Many even argue that good money shouldn't be wasted on gravel roads because it's like trying to make a silk purse out of a sow's ear. But people's attitudes aside, we're not likely to see most of our gravel roads paved anytime soon. They've been around a long time and are here to stay. Like paved roads, gravel roads should be constructed to minimum design standards and maintained that way as long as possible. They should have a traveled way, a shoulder on each side, and roadside ditches. Their surface should have a modified A-crown, with the travel lanes sloping down from the center of the road for drainage. The surface layer must be strong enough to prevent overstressing the subgrade, stable enough to resist raveling, shoving, rutting, and consolidation within the layer, and smooth and skid-resistant enough for a comfortable, safe ride. Gravel roads are greatly affected by their surroundings, from high mountains to low coastal areas, from cold regions to hot environments. from wetlands to deserts, from hills to flat terrain, and from open countryside to dense forest. But with all this variety in their environments, the most influential factor of all is moisture. A wise old sage once observed that there are 3 keys to maintaining any road: drainage, drainage, and drainage, in that order. Seriously though, there are 3 important aspects of drainage: getting water off the road, out of the road, and away from the road. Do all 3, and you can maintain any gravel road. Getting water off the road is the function of the road's crown and cross-section. A properly sloped surface allows the water to flow off the traveled way, down the shoulders and foreslopes, and into the ditches. Getting or keeping water out of the road is accomplished by maintaining the surface free of flat areas, obstructions, and depressions that will hold water until it weakens the gravel layer and penetrates into the roadbed. Keeping water out is also dependent on building the road at the proper elevation so that it's above the water table. Getting water away from the road is the function of ditches and culverts. Ditches carry the runoff alongside the road until it outlets into culverts, streams, or holding areas. Water, however, is not always an enemy of gravel roads. In fact, in the proper amounts, it's a vital ally, as you'll see in a minute. Perhaps the most important element in the success or failure of any roadway is what it's made of. Material characteristics determine how well and how long the structure will function. Mineral aggregate is the primary component of gravel roads. Crushed stone, gravel, and natural sands are the most common types of aggregate. But with other mineral materials plentiful in many areas of the country, and some areas lacking natural materials altogether, you'll also see slag, shale, chert, crushed basalt, shell, and even some natural soils in use. Not all kinds of gravel are good for road surfacing. Some types break down into fine particles under heavy traffic. Others swell when wet. Still others are so hard they're difficult to work. Good gravel supports the weight of traffic and distributes it enough to protect the subgrade. It remains tightly bound in dry weather to resist dusting and also sheds water in wet weather. Furthermore, good gravel for road surfacing contains a blend of particle sizes. The different sizes packed together, with smaller ones filling the gaps among the bigger ones to form a dense interlocked mass. On the other hand, gravel with particles of all the same size won't pack together into a dense stable mass, but will remain loose. A good blend of particle sizes is a gradation that ranges from a maximum size of about 20 millimeters down to very small or fine material having the consistency of flour. In fact, the difference between the gradations of good base course gravel and good surfacing gravel is the presence of more of these fines in the surfacing material. Because of it, surfacing gravel is sometimes described as dirty. The fine material serves 2 essential purposes. First, by filling the voids among the larger or coarse aggregate particles, the fines act as a binder that holds the total gravel mixture together and helps it form a dense, tight mass when the water content is correct and compaction is applied. A measure of this binding ability is called plasticity index, or PI for short. The higher the PI, the better the binding effect. Second, fines are also needed for their crust-forming ability. A hard, tight surface crust on a gravel road bears traffic loads and sheds water. A minute or two ago, it was said that water can be an ally of gravel roads. In fact, to form a hard, tight crust, water is essential. That's because the fines need moisture to turn them into the cement that binds the larger particles together. Another characteristic of good gravel for road surfacing is angular shape. The particles need to be angular, have sharp edges and flat faces to interlock properly. Angular gravel occurs naturally in some areas, or it's a byproduct of manufacturing, such as slag, or it's produced at crushing plants. But in many parts of the country, natural deposits of stone and gravel consist of rounded material. The rounded shapes of such gravel don't allow it to compact and interlock well, even with the presence of sand and fines. Rounded gravel particles act like marbles or ball bearings. Imagine trying to form them into a tight, stable layer. You just can't do it. The control and handling of gravels greatly affect their suitability for surfacing roads. Pit, crusher, stockpiling, and blading operations can either help or hinder the quality. Some examples. At gravel pits like this one, loader operators should remove material from the full face of the pit wall to obtain a complete and uniform blend, not from a narrow band. Crushers need to be set up and operated properly. For one thing, they need to be level. A plant that's out of kilter may segregate the crushed material, that is, separate the particles by size so that the material is not uniformly blended. Also, the screens must be in good shape, not clogged or full of holes. Faulty screens may allow oversized stone in the gravel or interfere with the desired gradation. Stockpiling practices can affect gravel quality too. Start with the basic site. It should allow for proper drainage and be cleared of debris and vegetation so that the gravel isn't contaminated when it's placed there. There should be ample room to place stockpiles of different material without having them intermingle. As much as possible, stockpiles should be built in layers rather than in cone shapes. Cone-shaped piles allow larger gravel particles to run down the steep slopes and segregate from the rest of the material. Removing the gravel from stockpiles is important too. Loader operators should keep their buckets above the bottom of the pile to avoid picking up any base materials such as clay, oversized stones, vegetation, etc. Loader operators can get a better blend of gravel from the ends of stockpiles rather than from the side slopes. This way, material can be taken from the pile's full cross-section. Even during blading, the suitability of the material is affected by the angle and pitch of the grader's moldboard. But more on this later. For now, we'll stop right here. Recognizing the environments in which gravel roads function, understanding the characteristics of the materials they're made of, and knowing that there are right and wrong ways of working with these materials are a good beginning to dealing with the problems associated with gravel roads. In Part 2, we'll look at those problems, including their causes, prevention, and correction.
The next video will be Pothole Repairs. This is a very important video for you to watch. This video will show you exactly what to do or what to watch when the contractor comes to repair your potholes in your roads. Do not try to do circle repairs for your potholes. Make sure they're nice straight edges, and make sure they are in square or rectangular form. That way you will get a longer life out of your roads.
Potholes are a major inconvenience, a safety hazard, and are damaging to vehicles. This program covers procedures for repair of potholes in asphalt concrete pavement. It focuses on the materials and equipment used in pothole repair and the procedures for making a permanent repair. Potholes must be repaired quickly because they are a hazard. They can cause serious accidents, and they slow down the flow of traffic. It's important to follow the correct procedures for repairing potholes. You'll save money, and you'll ensure that the repair will last longer. Potholes are caused when traffic breaks up a weak spot in the pavement. Several factors can contribute to weak spots. Among them, overweight vehicles, construction flaws, or water. Another major cause is repairs not done right the first time. A poor repair job like this won't last more than a few days. On the job, you'll see many sizes and shapes of potholes. Some will be shallow, some deep, and some will be irregular. The repair procedures are basically the same no matter what the size or shape. Pothole repair involves 9 steps: placing traffic control devices, marking the defective area to be repaired, cutting out the defective material, cleaning out the hole, applying the tack material, placing the mix, compacting the mix, cleaning up the job site, and preparing to move to the next job site. Let's look at each work step in detail. The first step covers placing traffic control devices. You are responsible for the safety of the crew and motorists. Observe the work area and decide where to place control devices. Place signs, cones, and barricades so they can be seen by drivers in time for them to react. If required, position flagmen at appropriate sites. Follow your traffic control standards and procedures. The second step is to mark the defective area. First, sweep away loose material from the pothole. Examine the area carefully to see the extent of the weakened pavement. Then mark the area to be removed. Use chalk, crayon, or paint to mark the edges. Generally, you can use the width of an outstretched hand as a guide to be sure that you mark the area in good pavement. Anything more may result in the unnecessary removal of good pavement. Mark the repair area in a rectangular shape with straight sides and square corners. This is a step you should perform so your workers have clear instructions. And remember, you may have to enlarge the area once the cutting begins and you get a better look at subsurface conditions. Repair areas don't necessarily have to be square, but never use a round shape. Adapt the outline to the shape of the pothole. The third step involves cutting out the defective material. To do the cutting, you'll be using either a jackhammer with a spade bit or a pickaxe. The cutting action should always begin in the center and proceed toward the edges. This has 2 advantages. There is less resistance to cutting, and you'll not weaken the good pavement outside of the marked edge. Also avoid rocking the spade bit, because this will damage the good pavement. Vertical sides are essential for proper compaction of the patch. Always check the sides with something square to make sure that they are vertical. This, along with compaction, is one of the 2 most important steps for a permanent repair. Be sure to cut down to stable material. It will form a good foundation for the patch. Also make sure that the bottom is level. The 4th step is the removal of defective material. A patch adheres best to a clean surface. Using shovels, remove all loose materials and debris from the hole. Next, blow out the fine materials using an air compressor, or sweep it out using a stiff bristled broom. Dispose of debris properly. Do not leave materials in the roadway, on the shoulder, or in a drainage ditch. Material left in the ditch will cause the water to pond and may result in another pothole. Next, make a thorough inspection to see that no weakened material remains on the sides or bottom of the hole or in the corners. Once all loose material is removed, you're ready for tacking. Tacking the hole is step 5. Tack serves as a kind of a glue to bond the patch in place. Apply tack to the sides of the hole first. Do not overlap onto the surrounding pavement. Use either a hand broom or a sprayer. Remember, tack should never be poured. It should form a thin film on the sides and the bottom of the hole, allowing the texture to show through. Pouring results in excess tack, which will soften the patch and cause it to break up. The materials you'll use for tacking are either emulsions or cutbacks. Emulsion is preferred. It requires only a little curing before putting premix in the pothole. Also, you can apply it to damp surfaces. Cutback is less desirable as a tack since it must cure at least 15 minutes. Also, cutbacks may require additional heating for ease of handling. You can recognize cutback by its gasoline or kerosene smell. In some cases, you'll have to cut out the damaged material down to the granular base. In this situation, apply a heavier coat of tack to the bottom of the hole. This is called priming. It acts as waterproofing. Properly cured tack is sticky to the touch. Remember, if you apply too much tack, the patching material will be weakened. But if you apply too little tack, the patch will not stick properly. Step 6 involves placing the premix material. Whether you're using hot mix or cold mix, make sure it's workable. Don't use it if it's hard to shovel or it's crusted. Begin placing the premix using a square pointed shovel. Begin in the corners and sides first. Then place material in the center. If the hole is deep, it may require several layers of material. Generally, the maximum depth to use for each layer is 8 centimeters in uncompacted layers. This is equivalent to the width of a hand. After placing each layer, spread it level with a rake. Make sure you keep all patch material in the hole. Mix left on the pavement around the hole will make the next step harder. Place additional layers only after compacting previous layers. Leave the uncompacted surface layer of the patch slightly higher than the surrounding pavement surface to allow for compaction. Step 7 involves compacting the premix. Compaction, along with making the sides of the hole vertical, is one of the 2 most important steps. Good compaction makes the patch last a long time. To compact the patch, you can use several different types of equipment. The best type is the vibratory roller. It works better and faster. You can also use a vibratory plate, a tandem steel-wheeled roller, or a hand tamp. A hand tamp is not the best tool to use. If it's the only compaction tool available, tamp especially thoroughly and use thinner layers, about 1/2 the width of a hand. If you use a roller, make sure the area around the patch is clear of debris prior to compaction. Debris under the roller will cause poor compaction. Remember, if the hole is deep, it may require several layers. Compact each layer thoroughly prior to placing another layer. Whether you're placing 1 or 2 layers, the procedures are the same. Always start compacting in the corners and edges. Then work in toward the center of the patch. First, make 1 or 2 passes without vibration. Otherwise, the machine will push uncompacted premix out of the patch. Then make a minimum of 10 to 15 passes with vibration. You can tell when the patch is thoroughly compacted because repeated applications of the compactor won't leave any impressions in the patch surface. Leave the final surface of the patch slightly rounded above the surrounding pavement. Check the rounding with a straight edge, in the direction of traffic, and across the roadway. The center of the patch should be about the thickness of a pencil above the pavement. This helps drain any water away from the patch. Next is step 8. You should make sure the crew cleans up the job site. Dispose of excess material properly. Once again, don't throw debris onto the shoulder, in ditches, or near catch basins. It will cause drainage problems. Load it onto the truck or dump it in a designated area. There's still one last step before the repair is complete. Step 9, preparing for the move to the next job site. First, count all the hand tools and equipment, and make sure that tools and equipment are properly cleaned and nothing is broken. As the equipment is being loaded, make a final inspection of the job site. Make sure that nothing is being left behind and the work site is left in proper condition. Also, remove and load traffic control devices in the reverse order in which they were originally placed. Follow your standards for traffic control to make sure it is done correctly. As the crew loads the devices, make a final security check to see that all equipment is secured before moving on to the next job site. Before we finish, let's quickly review each of the 9 steps of pothole repair. The 9 steps include placing traffic control devices, marking the defective area to be repaired, cutting out the defective material, cleaning out the hole, applying the tack material, placing the mix, compacting the mix, cleaning up the job site, and preparing to move to the next job site. Following the procedures presented in this program will result in professional, long-lasting repairs, which will benefit you, your crew, and the driving public.
The next video will be pavement patching. This video is actually of a road, but it gives you a good demonstration on what you should be looking for when the contractor is out patching your road. Pavement patching and pothole patching are similar. It's just that pavement patching is a lot larger.
Learning construction. Learn, share, expand.
Crack sealing of your cracks in your roads are needed because that is one of the cheapest way to maintain and extend the life of your roads. Contractors will come in and want to do several things, but crack sealing, routing, and then sealing of the cracks is the best way for you to go. And there are 3 videos for that too that are on our McHenry Division of Transportation webpage. So please watch all 3 videos.
Thank you, Kevin. I'd like to see a show of hands. How many people here are from agencies? So how many contractors and suppliers do we have in the room right now? Okay, my question to you from the agencies would be, how many consider that your agency has an aggressive crack sealing or crack filling program? So we have a couple hands. From the contractors in the room, how many contractors or suppliers actually do crack sealing and crack filling? Could you raise your hand? So we have 1, 2, 3, 4, 5, 6. Okay. One of the things that is really important is crack sealing and crack filling, in my opinion, because that is one of the early things we can do when we address the pavements early, or it's one of these treatments that we're going to call the top of the curve. And it's interesting to note that agencies that do or have an aggressive crack sealing and crack filling program really do not have the pothole problems. And a lot of the major distresses that we see in the roads are eliminated if we can actually get into an aggressive crack sealing or crack filling program. One of the things, and we talk about this through the partnerships, is terminology. Because the terminology is all over the board when it comes to talking about crack sealing and crack filling, because they're 2 entirely separate operations. They perform more or less the same function, but the way they're handled is completely different. I'm going to restrict this conversation with you today for asphalt type pavements, flexible pavements. We can do the crack sealing operation on a rigid pavement, and generally speaking, we would crack seal a rigid pavement if it had a crack over 3 feet in length and maybe over 1/8 inch in width. We could begin to look at crack sealing. But I'm going to restrict this discussion to flexible pavements. Before I get into, well, what's the difference between crack sealing and crack filling, we have to understand some basics. And one of the basics that we look at to decide whether or not we're going to do crack sealing or crack filling is whether or not we're trying to address a working crack in a pavement. Working cracks are those cracks that are going to move greater than 1/8 of an inch. Well, you and I both know nobody's going to go out there and take a ruler or a micrometer and try to measure those crack movements. I mean, we're not going to spend the time for that. And the crack filling is really those cracks that are non-working, or those that don't move at all or much at all. And their restricted movement is less than 1/8 of an inch. So what does all of this mean? Well, let me jump ahead once. That's not exactly where I thought the slide would be. Another thing we have to look at between crack sealing and crack filling is the type of crack we have out there. If we have a primary crack, that means a single crack going across the roadway, then early on we can address crack sealing. And I'll tell you what crack sealing is in a minute. Whoops, I didn't want to do that. Primary crack, where you have a single crack going across the roadway, would be a candidate for crack sealing. When you have a crack and it's been out there a little bit too long, you begin to get secondary cracks. And secondary cracks generally radiate out from the primary crack. And at that point, it's probably a better candidate for a crack fill operation. Although you could, if there wasn't a lot of secondary cracking, you could probably do some crack sealing. So between the working cracks and the type of crack you're dealing with will help you determine whether it's a crack seal or a crack fill operation. So what exactly is crack sealing as opposed to crack filling? Crack sealing is where we actually create a reservoir in the crack. And we address working cracks, and we need that reservoir to hold enough material that will have adhesive properties that will bind to the sidewall of that crack. So as the crack opens up in the wintertime and closes in the summertime, that material has a reservoir to actually seat into. And that's an important part of crack sealing. So my first question is, where would we do crack sealing? Primarily, we're going to do crack sealing on primary transverse cracks. Those are your working cracks. By and large, those are the cracks that are going to move. Your thermal cracks are the ones that are going to move. And the equipment that would be used for crack sealing and crack filling is somewhat identical. You're going to have a kettle or a melter applicator, something like this. And it's got some important features because you definitely want to size the kettle for the needs of the job. In other words, if you have a kettle that's much too small, you're going to constantly be recharging that kettle with material. It doesn't seem like a big deal, and I'll tell you why it is in a minute. If you get a kettle that's too large, then you may roll back in at night and have excess material within the kettle that may have to be reheated for the next day. You see, the sealants are critical to the success of a crack sealing and crack filling operation. And it's very important for the owner agency to understand what sealants are going to go into that kettle, because based on the manufacturer's recommendations, some sealants shouldn't be reheated any more than one time. Some sealants can be reheated more than one time. So you really have to read the material sheet. Within the kettle, and that's the center part, I haven't got a laser here, but within the center part of the machine there, we have a kettle, and it's oil jacketed, but there is a paddle system in there, or an agitator, that actually keeps the material moving. And so we want to keep a constant mixing action. It doesn't move fast, but it keeps everything flowing within the machine. It's also very, very critical on a crack sealing or crack filling operation to have the proper controls that we know we're going to get the materials up to the proper temperature. If we do not heat the materials up to the proper temperature, we overheat them, we could lose some of our sealant properties. If we do not bring them up to temperature, then they're not going to perform properly. So that goes back to why we don't want to continually charge or recharge that kettle, because if we're recharging the kettle, it's going to take time to bring the materials back up to temperature. And in a production operation, you want to have the temperatures pretty much established rather than running the machine low and then trying to recharge it and wait for it to bring the materials up to temperature. It's critical we have a thermometer, and probably 2 thermometers is most critical. But your newer equipment will also not only show the temperatures within the kettle, but it will show the temperatures within the wand itself or within the hose system. So we always have control of what the temperatures of the sealant is. There's a couple ways we can create that reservoir in a crack. One of them is with a router. And this is a typical router, and you can see the cutter head on the lower left part of the screen. And it's interesting how these operate, because if you take a look at the lower part of that unit and you tip it up, there is a large wheel in there that the cutters actually mount into, and I'll show you a little better picture of it than this. This is actually that wheel, or the cutter assembly, that fits within the machine, and the wheel is what moves, not the actual cutters. The cutters are free to rotate with the force. And this wheel actually moves what we would consider backwards, so the person operating this machine to route the cracks is going to pull that machine backwards, or the cutter, the router is actually going to be pulled backwards. It would be very difficult to push it forward. It probably could be done, but you're going to pull it backward and follow the crack right along. So now, depending on the width of your reservoir, these heads may be doubled up. And so depending on the I'm going to call it the shank or the flange of that particular cutter, you may mount two cutters side by side on each individual pin. And so, like I say, those cutters, they spin, but they're not power driven. The wheel is what's power driven. The other opportunity to create a reservoir is with a random crack saw. And the random crack saw is a dry operation. It doesn't require water. And the blades here are generally 8-inch diameter, and they're usually a diamond impregnated blade that can be recycled. And this machine actually cuts rather than routes a reservoir. And there's one additional step with that we'll get into anytime you saw a crack. One of the concerns, let me back up, with these cutters, we want a rectangular reservoir. And a contractor has to continually monitor the shape of the reservoir, because those cutters have to be changed on a fairly, depending on how good of cutter we have. If we have a carbide tip, they'll probably last much longer. But they will have to be changed on occasion. And we definitely want the reservoir to look like this, but if they get dull, that reservoir can begin to take a U shape and maybe even a V shape in later stages. So it's extremely important to have those cutters creating the proper reservoir configuration. With a random crack saw, and one of the advantages here is once those blades get dull, you can no longer push that crack saw to create the reservoir. So it's more or less of a safety issue, or not a safety, but it's a quality control issue. That's a better way to say it. And so those blades are constantly going to have to be changed when they get dull, but you won't have to worry about losing your shape factor. The air compressor, it seems harmless enough, but one of the issues in crack sealing is to keep the crack extremely clean. And so we need an air dryer on every compressor. And you know that if you take any kind of compressor in the summertime, you're going to literally draw moisture right into the compressed air stream based on the humidity in the air. And so in essence, if we haven't got a dryer that's on that compressor, we can blow moisture right back into the reservoir. And of course, sealants and moisture really don't respond well together, and we're not going to get the proper adhesion. The other thing we need on that compressor is an oil filler, and I'm not talking about an oil filler on the actual engine. I'm talking about an in-stream oil filter, because you get a certain amount of blow-by, particularly with an old compressor, that the oil from the actual machine, the crankcase itself, can blow by the rings and literally wind up in the airstream. So those are two important factors that you need on that compressor. So we have two procedures that we could use for crack sealing. And crack sealing is the router method or the crack sawing method, but you can see that the router method, there's one difference, and that is that we do not have to sandblast or scuff up the sidewalls of the reservoir, because anytime we use a saw, we're going to create a sheen or a potential lattice on the sidewall of that reservoir that we have to clean off. And so there's a light sandblasting operation that, of course, adds costs, slows the operation down. But nonetheless, those are the two standards right there for crack sealing. We talk about attention to detail, and it's critical here because sometimes we shoot ourselves in the foot by not looking at the attention to detail. In other words, we can't have slivers in the sidewall. We can't have dust on the sidewall. Talk about the white glove test. We should be able to run our hand along that reservoir, and we should have a clean sidewall. So there should not be any dust or debris within the reservoir once it's prepared. And then we're going to put the material into the reservoir, and usually on crack sealing it's a flush fill operation. And this would be a finished or a sealed transverse crack or a working crack. Now let's talk about crack filling, because a lot of times agencies confuse sealing and filling, and like I said earlier, they're two different operations. As I said before, we are targeting non-working cracks. Well, what's a non-working crack? I mean, we know that they don't move 1/8 of an inch, but we're not going to go out and measure them anyway. Generally, and I say generally, your longitudinal or diagonal cracks are non-working. So that would be where you would use a crack fill operation. It's a simple procedure. We use the air compressor and we blow the crack clean. And then we come along with the sealant and we fill the crack with sealant. And there's different configurations that can be used, but the most popular, I think, across the United States is a simple overband configuration for crack filling. This is a typical crack. It's usually got debris in there of some sort. You'll blow that crack clean. And this is a very simplistic approach. And then you'll come along and you'll fill that crack with sealant, and you'll put that small overband cap with a special tool on the end of the wand, and I'll show you that in a minute. And you'll literally seal up that crack, fill the crack. This is a typical overband configuration. The wand has a disc on the end of it, and it's prudent to have no more than 3 inches of width in the overband configuration. And why do we say that? Is because it's my understanding we can probably get discs that will fit on the end of that wand that are up to 12-inch diameter. The problem is that that could get potentially pretty slippery when it gets wet. And so it's very prudent to select our roads properly. Do them when they're early on in their life. Don't wait until the deterioration has occurred to the point that we literally paint the roadway. So keep it within the 3-inch bandwidth. And this is a shot of a typical wand and the disc. And you can get a disc that is fixed, or you can get one with a swivel head, which is almost like a ball joint there that allows that disc to swivel. And this is a picture of the actual disc head. This is a swivel mount, and on the bottom of that disc it's concave that allows the material to flow through the wand into the disc head, and that's how you apply the material in the overband configuration. This is one of the old ways. Gosh, I don't even know the name of that end. Do you know what that particular wand is called? What is it? A shoe? Okay. You know, there's simple things we can do that will literally save us hundreds of thousands of dollars. And one of the concerns that agencies are always having is the tort liability issues on freeways, particularly when you have an asphalt shoulder and a concrete main line. And asphalt, concrete really don't bond that well together if you think about it. And that longitudinal joint between the asphalt shoulder and the concrete road usually opens up after about the first year. Now, we make a big issue about sealing our roadway or filling the cracks in our road, but on that particular road, where's the water going to run? it's the cross section. So it's going to run right to the joint, or the longitudinal joint at the shoulder. And if that is open, we're going to literally allow the water to go right down into that joint, and it will eventually soften the base underneath that asphalt shoulder. And so this is an opportunity to do some basic crack filling. If we early on had run a bead of overband right down between the shoulder and the concrete main line, seal that joint, we would have eliminated the water infiltration. And we could probably added years of life to that shoulder. Simple things. In a residential community, for example, where you have a curb and gutter section, again, the water is going to come off the center of the street, it's going to flow to that gutter pan, and like I said, the concrete and the asphalt don't necessarily like each other, and there's going to be an open joint right there. It's going to soften the base underneath that street, and we're going to see that type of fatigue cracking or alligator cracking, and we're going to see a settlement. The settlement occurs when the school bus or the garbage truck goes by and they begin to pump that material out. And so literally pennies can save us a ton of money. Same way with castings or structures. Anytime we put an asphalt around a manhole or catch basin, in time we're going to develop that joint or that seam where water is literally going to flow down around our structure. And that's why we have to rebuild these structures all the time, is because they get undermined by water and erosion of the water. If we can, or caused by the water. So if we would take an overband and just put it between that seam of the casting and the street or the asphalt, then we could eliminate that water infiltration. One of the things we have to really understand is where's an appropriate place to put these materials down. And, you know, a little bit is good, but a little more may be too much. And this is a case where we really had an improper selection. Those of you seeing where the overband crack fill was done, you probably could recognize what kind of distress that might be, because it's predominantly within the wheel paths. And it's likely it's fatigue cracking. And fatigue cracking is a structural issue. Now, it may delay it a little bit, but it's probably not the most healthy place to put down a standalone crack filling operation. So use some judgment. Catch your roads early before they get to the point that they're cracked to pieces, and apply your overband crack fill. Now, I haven't seen any kind of configuration of cracks that look like this, but nonetheless, this is the type of thing that I can share with you that no doubt the specification said we're going to pay for the material by the pound. And there was no inspector out on the job. And so some contractor took advantage of that, and that's really a shame. But here's the real safety factor. You get that kind of material on the roadway, or regardless where it is, and when that gets wet, it gets very, very slippery. You can probably kill a motorcyclist with that kind of material out there like that. And so it's serious business. Not to mention the economic factors involved, because it costs somebody somewhere some money. Sealant materials, we used to know it as D3405. I think there's been some changes in the ASTM spec, and now they call it either Type 1, Type 2, Type 3, or Type 4. I'm no expert in the sealant materials. I believe the Type 1s are used in very, very hot climates. The Type 2s are generally used in this part of the country, moderate temperate climates. Type 3s are, from what I understand, they're targeted mainly for airport uses, and the Type 4 are extremely bitter cold climates. So for us, we would no doubt use a Type 2 material. And with that, it's a quick run through. You've got some experts in this room that know far more about crack sealing and crack filling than I do, but I would certainly recommend for the agencies to get yourself into an aggressive crack sealing and crack filling program. It's one of the basic early things that we can do as far as pavement preservation. We can save our roads. You'll save the money. I tell you again and again, you'll make your money back in the elimination of potholes. And it's a whole lot safer to go out there in the work zone and do some crack filling or crack sealing than it is to go out there and patch potholes. So with that, I thank you for your time, unless you have some questions. Yes?
Your random crack saw, is that a dry or a wet cut?
The question was a random crack saw a dry or a wet cutter? It's a dry cutter. Yes. Any other questions? Yes.
You literally can use the hot lance. You see that?
The hot lance. There is a process that you can actually use a lance that has flames, and the purpose of that is to actually take some of the moisture out of the reservoir. You've got to be careful, because one of the concerns is that we can actually damage the pavement structure if we burn the asphalt along that reservoir. So, used by a trained individual, it's probably a good practice. For somebody that doesn't know what they're doing, they could probably do more damage than they could be doing good with a hot lance. What's the opinion of the contractors? Would you agree or disagree with that?
I think it's for drying a damp crack or reservoir. It's not to dry a reservoir.
And Jeff's comment was it's used to dry a damp crack or reservoir, not a wet crack.
For what you said, if you spend too much time with the heat lamps, you're going to damage the surrounding asphalt. It's very helpful at night, more and more work at night, more and more crack sealing at night.
So it's an operation that pretty much is used at night, just for the dampness. It's literally pennies here. I mean, we talk about cost effectiveness of pavement preservation. There are some very effective and cost effective things we can do. Crack sealing and crack filling are very, very cost effective. So I highly encourage agencies that aren't doing it to do it. Yes?
They've been doing for asphalt paving, the centerline joint crack, they've been putting the sealant in right at the application of that second layer against, so they're pre-applying the joint for the asphalt surface. How do you feel about where the concrete meets the asphalt shoulder? Has anybody had any experience with maybe using that centerline joint sealant when applying that final layer of the new asphalt shoulder versus coming back later and waiting for it to crack?
You're talking about a bonding type of agent during the paving operation, or you mean afterwards?
During the paving operation.
During the paving operation? I don't have experience with that. Maybe somebody in the room would have experience where you're using the actual bond mechanism up to a concrete.
Yeah, we did an experiment in a city where we used, you're talking about like the Craftsman joint adhesive. Yeah, we did that in a curb and gutter section in an urban section. And we're watching the operation. It went quite well.
Is it too early to tell right now, Roger? Okay, so the jury's still out on it.
How did it stay? You put it on the concrete face, Roger, or the curb?
Yeah, we put it on the face of the curb.
How did it stay on there?
Actually pretty good.
Staying out.
Any other questions? Yes?
Can you explain the difference between the fiber and the rubber? The end is what one or the other underneath the micro?
Oh, okay. Very good question. I've been talking about crack filling as a standalone operation, but this is where we can mix and match some of these treatments. And using a crack fill operation as a pre-treatment ahead of your chip seal or your micro surfacing or slurry operation is ideal. And if you have a good hot mix contractor and using thin hot mix overlays, we found if he has the proper drums, proper rollers, you can actually get away with putting down overband crack fill and not creating a bump or a bleed through. It takes a little bit of training, but it has to do everything with whether he's using a dual drive drum roller, and it has everything to do with the roller speed. But you can construct a hot mix road by sealing up the cracks first, or filling the cracks. I think the agencies, many of the agencies already do pre-treatment with overband before any of the surface treatments go down. The materials in the overband, and I talked about a type 2, but generally speaking, most materials have a rubber, they're an asphalt binder, they're a rubber, and they're a polyester fiber. And I think the ratio, the ratios are going to vary by the manufacturer, but usually it's 90% binder, 5% rubber, 5% fiber. I believe that's kind of a standard ratio. It may vary a little bit. The actual fiber itself keeps the material from separating quite as easy, and it seems to be very, very durable. And so it's, we work with your suppliers and your contractors, and they can really help you out. Don't just shoot into it and try it without working with them to identify good materials in the specification. They want success as much as you do, and so please use them. Did that kind of address the issue, or did you want to?
Yeah. You can go and talk about it all day, but because there are all the different advantages and disadvantages.
Okay, I think I've worn out my time. Thank you very much.
Slurry sealing, microsurfacing, and chip sealing. We're not going to go through those right now, but get on the web page and watch those also. Those videos will extend the life of your road. Those are for wearing surfaces. So this will be done after you get done paving your road. Those will, like I said, extend the life of your road. So you want to extend the life of your road as long as you can, because the longer you can extend the life, the less money you have to put into your road. The last video we will be showing you is for paving. This is a very important video, so please watch this very carefully. There are a lot of important things that I will point out to you in this video after you have watched it, but this will also be carried out later on with showing you how much mix asphalt you'll be needing and other things that I will be presenting later on that will help you out to discuss with the contractor when he comes to pave your road. you just watch this video, things to be looking for in this video is you see the gentleman poking that stick into the asphalt. That shows you how thick the pavement is. So watch him when he's doing that to make sure you are getting the correct thickness of the pavement when he is out there paving your road. Another part of that video, you saw the gentleman on the crew pick up a piece of asphalt from the edge of the road. Make sure the contractor walks along the edge of the road before he starts paving and picks up all the loose asphalt. You don't want that underneath your road because it just becomes a piece of loose material which presents cracks, and then you'll get a pothole at that part of your road where you have loose material underneath it. I'm going to go over potholes right now, what they look like right now and what they should be. As you see on the screen, the video shows pothole repairs. You see circled potholes and you see potholes that have jagged edges. Underneath that, you'll see how they have been reduced to nice square cutouts or a rectangular piece, but make sure you have nice square edges and vertical edges on your potholes when the contractor is performing the work, because you'll get a longer life out of your potholes if the contractor does that for you. We'll go into some forms now that you'll have to fill out. These forms are critical because some of them have to be filled out for you to tell the township what work you want done, and also for the county on what work you had and the contractor's information and your information of the time that you put in. This first form is a memorandum that goes to the township every year, and it changes. So ask the township road commissioner for this form so you could review it every year to make sure that you are up to date on everything that is needed on a year-to-year basis. The second page of this form gives you information about the repairs that you can do using motor fuel tax funds. So review these every year also. This is a page or sheet that shows you how to quantify your square yardage of your road. There are two things you must do. On the top of the page is the length of the road. What you want to do is measure the whole length of the road and then take measurements across the road. Several of those measurements you need to take across the road to make sure you get an average width of your road. And that will show you the square yardage for the length of your road. Then you want to also measure the radiuses of the road. And what I'm talking about is where you enter in from another road onto your road. Measure that also. And those two total together will give you the square yardage of your road. And that square yardage you'll be using in further calculations that I'll be showing you here shortly. This is calculating the amount of asphalt, or I should say hot mix asphalt, that you'll be using on your road. This first calculation is that square yardage that we just calculated previously times the depth, which is, we have in there right now 1.5, times the weight of the material, and that is 112 pounds per square inch per yard. And if you have anything deeper than 1.5 inches that you want to put down, you just put that in where the 1.5 inches is at in this calculation. Then you multiply those three top numbers and you come up with the total number figure, and then you divide that by 2,000, and that will give you the total tonnage of asphalt you'll be needing on your road. The next figure you see is for crack sealing. When you talk to the contractor about crack sealing, the best way to do this is 3/4 by 3/4, and what I mean is a wall depth of 3/4 of an inch and a width of 3/4 of an inch. And that will give you the best possible way to make sure that crack sealant that is put into that routed out crack will stay the longest during snow plowing every year. You'll get the longevity that you would want out of it, so you don't have to do it every year. The next one is the gallons for seal coating. You use your square yardage that you have previously times the weight of the seal coating, whatever that is, how thickness you want to put that down at. And it usually, what I have in there now is like 0.08. You multiply the square yardage times 0.08 and you have the gallons that you'll have, that you'll talk to the contractor, I need that many gallons of seal coat to do our road. Chip sealing, you want to multiply your square yardage times 0.5, and that will give you the gallons of how much chip sealing material you will need to put on your road. And then for the tonnage, because you have to put gravel on top of chip sealing, you use your square yardage times 3 pounds, and that will give you how much material you'll have to put down. We'll go on to this form now, application form. This is what each township should be giving the non-dedicated road so they can fill this out of what they want to do that summer with the motor fuel tax funds. So when you, every spring, ask for this from the township for all the forms that you will be picking up. This is a variation of the previous form. It's for the contractor. Contractors have to use prevailing wage for paying all of their employees. If they don't do that, they cannot receive MFT monies. And this form, you have to have them fill out to make sure that you have forewarned them that they have to pay prevailing wage on any work that they do for you using MFT funds. Other information pertaining to the contractor doing work also is they have to use certified materials. And the certified wages, or the prevailing wages and the certified materials can be found on our webpage, links to the Department of Labor and the Illinois Department of Transportation that will show you the information that you need to know about the certified materials and the prevailing wages that the contractor has to be using when you review this, when he submits the invoice to you. This has to be filled out by the contractor and submitted with the invoice. This shows us and you the employees that he used, the minimum wage that he used, or the prevailing wage that he used, and the work that he was doing, because you will need the work that he was doing with his laborers to make sure that he is paying the correct wage to his laborers that is doing the work in your subdivision. This is for you. You have to fill out, the people that are living on the non-dedicated subdivision road have to fill out these columns. There's a lot of ways that you could have matching funds on this form. So pay close attention to each columns that are on this form. Preparation of documents, that's one way you can collect hours that will be used toward your matching funds. Inspecting the areas, that could be used towards matching funds. Preparation of the request of the forms the township gives you, that could be used for matching funds. I'll skip through it and go right over to review of the contractor's materials, that could be used. Maintenance of the roadway, that's within the right-of-ways of the road. Anybody that lives in your subdivision and can be doing work in that area, and that can be used for matching funds, because each resident that does work in that area can collect hours at $36.20 an hour, and you can find that on the Illinois Department of Labor also, because that will change from year to year. So everything on this form that you see, you could use towards matching the funds that you get from the township. This is the invoice that you will give to the contractor. Sometimes contractors will have their own invoice. As long as it has this information on it, we will be able to accept it at McHenry County DOT. If the contractor does not have an invoice, make sure you give him this invoice so he can fill it out and provide all of the information that is needed to pay his invoice. And those are the examples of the paperwork that you'll be needing, not only to submit with the invoice, but also to just give back to the township to make sure that you are getting the work done that is needed to be done on your roads. Okay, this is the purchase authorization form that you'll be getting with the rest of your paperwork from the township. You have to fill this out, give it back to the township, and make sure you get a copy of this with the road commissioner's signature on it so you can give this to the contractor. And this provides us information when it gets submitted with the invoice that the contractor has done the work for you and you are okay with the work. This is a sample of an invoice. This was through a contractor, so contractors might have this type of invoice with this information on it. This would be good to submit with the rest of the paperwork to get paid. Another invoice. This is a load ticket that will have to be submitted with the invoice also. If they use aggregates or HMA materials, you will have to have this ticket submitted with the invoice or else the invoice will not be paid. Another example of an invoice. This is an example of an aggregate ticket that we get from the contractor so the contractor can get paid for putting aggregate down on your roads. Another copy of an invoice. Another ticket from a contractor. Another invoice. This is another ticket that the contractor needs to provide when they submit the invoice. This is a list of items on our webpage that you can go to that will give you links to all the sites that I have talked to about previously and the forms that you'll be needing also. So it is very important. I'll go over one more time with you on what needs to be submitted when the contractor wants to get paid. He will submit the invoice to you with the purchase authorization, the invoice, and the tickets, either aggregate tickets or HMA tickets, and also his submittal of the workers that he had perform work during his work on your road. After you have reviewed those, you will submit those to the road commissioner. He will review them, and then they'll have your signature on it and the road commissioner's signatures on it, and then that will be submitted to us, and we will pay the contractor. And then one more thing, you will not be able to pay the contractor directly. The contractor only gets paid from McHenry County DOT. In the past, if you have paid the contractor directly, that will change. You will have to send a check to McHenry County DOT, and then we will deposit it into the road district's bank account. And then when the invoice comes for that contractor, we will use that fund and the MFT funds to pay that contractor. Everything that has been shown today and everything that I have mentioned today can be found on McHenry County DOT webpage. So please look at that and go to where the forms are and the links are, and you should be able to get everything you need. If not, like I said previously, contact the road commissioner and he can contact us and we can get to you the appropriate information. Thank you.